it is recommended that to watch this video in high picture quality, and here we will discuss about from question 1 to question 30, and we will discuss from question 1 to question 30, and the type of question, that is question 31 to question 40, is not currently in our syllabus, so we just avoid these questions. So we would mainly discuss from 1 to 30. In this video, we will be discussing about Chemistry Paper 1, MCQ Paper 2017 October-November, variant is 11, and the subject code is 9701. In question number 1, which formula represents the empirical formula of a compound? So this formula can be further simplified. So this formula, this is also further simplified. This is also further simplified. So these are not the empirical formula, but this formula represents the empirical formula because it cannot be further simplified. So the answer is A. Question number 2. The relative first ionization energies of 4 elements with consecutive atomic numbers below 20 are shown in the graph. So 4 consecutive elements with atomic number below 20. One of the elements reacts with hydrogen to form a covalent compound with the formula HX. Since this is a covalent compound and it forms HX, okay, so we note this, then which element could be X? So according to the periodic table, so 4 consecutive elements, so these consecutive elements can be any of the elements with the atomic number below 20, and as we can see that from the graph, as we can see here, that this ionization energy and after this ionization energy there is a large decrease. That means these two elements are in the same period and this element is in the next period. So, and these elements are consecutive elements with the atomic number below 20. So consecutive elements, and these two are on the same period and this is on the different period. So we can see that, and it forms a covalent bond with hydrogen. So if we see these two elements that are fluorine, neon, then sodium, magnesium, these are 4 consecutive elements. After these two elements, the atomic number decreases, the first ionization energy decreases, so they are on the next period. So among these two elements, we can see that fluorine can react with hydrogen to form HF. So this is a covalent compound. So the answer should be fluorine. So fluorine, neon, sodium, magnesium. This is fluorine, neon, sodium, magnesium. So the correct answer is A, because these are the 4 consecutive elements, and this element, that is the fluorine, we suppose this is the fluorine, so it reacts with hydrogen to form HX with atomic number below 20, and these elements are consecutive elements. Question number 3. In which structure are 3 atoms bonded together in a straight line? So 3 atoms that are bonded together in a straight line. So polyethylene, if we draw the structure of polyethylene, then this is the structure, and here we can see that the bond angle is 109.5. So this is tetrahedral. So this is not a straight line, this is tetrahedral arrangement. The straight line would occur if suppose the bond angle is 180 degree. 180, or if it is 90, then straight line. So this can be the cases. So propane, so for propane, C3H8, so C3H8, again the bond angle is 109.5 degree. Silicon tetrachloride, again the bond angle is 109.5 degree. Then for sulfur hexafluoride, SF6, so sulfur, and there are 6 fluorine, so 1, 2, 3, 4, 5, 6, and for this sulfur hexafluoride, the bond angle is 90 degree. So this bond is 90 degree, and this is also 90, this is also 90. So that means this side is 180, this side is 180. That means this is a straight line. So for the straight line, the atoms are arranged in the straight line. So for number 3, the answer is D. Question number 4. In sodium chloride lattice, in the number of chloride ions surrounded by the sodium ion is called the coordination number of the sodium ion. What are the coordination number of sodium ion and chloride ion in the sodium chloride lattice? So in sodium chloride lattice, each sodium atom is surrounded by 6 chloride ion and each chloride ion is surrounded by 6 sodium ion. So the coordination number is 6 and 6. So the answer is C. In question number 5, a fluorescent light tube has an internal volume of 400 cm cube and internal pressure of 200 kilopascal. It is filled with 0.03 moles of ideal gas. What is the temperature of the gas inside the filament tube? So for this temperature, we need to find the temperature in Kelvin. So to find the temperature in Kelvin, we have given that this gas acts as an ideal gas. So for ideal gas, PV is equal to nRT. So we need to find the temperature. Temperature is equal to PV by nR. And we must convert the pressure to pascals instead of kilopascal, and the volume in terms of meter cube, not centimeter cube, and number of moles would be same, and the value of R, that is a constant, that is 8.31. So 8.31 number of moles, we need to convert the pressure into pascals, and the volume in cm cube to meter cube. So we get the temperature as 320.89, that is 3.21 in 10 to the power 2 Kelvin, that is B. In question number 6, one of the reactions in a lead acid cell is shown. So this is the reaction. Which statement about this reaction is correct? So lead is oxidized and reduced, neither oxidized or reduced. Lead is oxidized and it is reduced. So for lead, its oxidation state is 0, then PbO2. So in this formula, its oxidation state is +4, that is X plus -2 into 2 is equal to 0. So the value of X is +4. Then for PbSO4 to SO4, so SO4 is -2. So the oxidation state for lead is +2. So 0 to +2 is oxidation and +4 to +2 is reduction. So the answer is A. Question number 7. Iodine and propanol reacts according to the following equation. So if the concentration of propanol is increased, keeping the total reaction volume constant, the rate of the reaction also increases. So if concentration increases, the rate of the reaction increases. What could be the reason for this? So a greater proportion of collision is successful at higher concentration. So this statement is wrong because a greater proportion of collision is successful at higher temperature. So a greater proportion of collision is successful at higher temperature, not higher concentration. Then particles are further apart at higher concentration. No, this is wrong because at higher concentration, the particles are close together. The particles have more energy. More energy occurs if temperature increases. So this statement is wrong. There are more collision between the reactant molecules or reactant particles per second. So yes, this statement is correct because as the concentration increases, suppose this is a jar and this is the concentration, and if we just increase the concentration, now more molecules per unit volume, so more collision occurs, more molecules, so more collision occurs per second. Question number 8. Sulfur can be oxidized in two ways. Sulfur dioxide can be made from sulfur dioxide and oxygen. What is the standard enthalpy change for the reaction? So we need to find the standard enthalpy change for this reaction, that is the value of X. Standard enthalpy change for this reaction. So we have given the value of enthalpy change of formation of, or enthalpy change for this reaction and enthalpy change for this reaction. So initially, sulfur is solid and oxygen is gas, and sulfur reacts with oxygen to form sulfur dioxide. So sulfur dioxide is formed, and this energy is for the 1 mole of sulfur dioxide. But here we can see that we make 2 moles of sulfur dioxide. So we multiply this value by 2. Then for sulfur trioxide, we can see that initially it is 2 moles of sulfur trioxide, and here we can see that 2 moles of sulfur trioxide. So no change occurs, and we have to write the value as usual. So this is the value, and we need to find the value of X. So this arrow is pointing in this direction and this arrow is pointing in this direction. So this is the one path and this arrow is pointing in opposite direction. So this is the other path. So x plus this value minus this value, that is x plus negative 296.5 into 2 is equal to negative 791.4. So we get the value of x, that is negative 198.4 kilojoules, that is T. Question number 9. Hydrogen iodide dissociates into hydrogen and iodine. So hydrogen iodide dissociates into hydrogen and iodine. In an experiment, B moles of hydrogen iodide were put in the sealed vessel at a pressure P. So initial, that is, in an experiment, this much mole is put into the reaction vessel, that is the initial number of moles of hydrogen iodide, that is B. Then at a pressure P, at equilibrium, X moles of hydrogen iodide are dissociated. That means X mole is dissociated. So what is the remaining mole? This much mole is dissociated, that means converted to hydrogen and iodine. So what is the remaining moles at equilibrium? So the remaining moles would be B minus X. That means this is dissociated and this is the initial. So the remaining mole is B minus X. And what is the change? For 2 moles of hydrogen iodide, the change is X. So for 1 mole of hydrogen and 1 mole of iodine, the change is X by 2. Since it is for 2 moles, so for 1 mole it is X by 2 and 1 mole of iodine it is X by 2. So at equilibrium, we get the number of moles of hydrogen and iodine as X by 2. That is, both are present in terms of X by 2 moles. So what is the value of Kp? So Kp is equal to partial pressure of hydrogen into partial pressure of iodine by partial pressure of hydrogen iodide. So what is the partial pressure? Partial pressure is equal to number of moles into the total pressure, that is X by 2 into total pressure into X by 2 into total pressure, that is the number of moles of hydrogen and iodine at equilibrium, divided by the number of moles of hydrogen iodide, that is that is present at equilibrium, that is B minus X. And since there are 2 moles, so we need to place a square, and it is also multiplied with P square. So these P values cancel each other out, and after cancelling this value, we get X by 4, X square by 4, and X square by 4 divided by B minus X square. So the answer should be answer D. Question number 10. The diagram shows the distribution of molar energies in a sample of gas at temperature T1. So this is for the temperature T1, and this is the proportion of gas with the given energy, and this is the energy. So this is basically the number of moles of gas, and this is the energy. The activation energy of an uncatalyzed reaction of the gas is EA. So this is the activation energy when no catalyst is being used. So this is the activation energy when no catalyst is used, which diagram correctly shows the new distribution and the new activation energy when the temperature is increased to T2 and the catalyst is used, that increases the rate of the reaction. So what is the distribution when temperature increases? As temperature increases, so the shape of the graph would something look like this, that is this shape. So the curve should move forward, or the hump should move forward. So it is moving backward, so this is wrong. It is also moving backward, so this is wrong. This is moving forward and this is moving forward, and it is downward curve. So yes, this is correct. So either C or D. Then this is the activation energy for uncatalyzed reaction, and for a catalyzed reaction more molecules have energy, so the activation energy moves towards the left. So EA moves towards the left for a catalyzed reaction. So here we can see that EA moves to right, so this is wrong. And here we can see that EA catalyst moves to left, so this statement is correct. So the answer is C. 200 gram of water at 25 degrees centigrade. The water is heated to 75 degrees centigrade by burning 2 gram of ethanol. What is the amount of energy transferred to water? So we need to find the amount of energy, or just the value of Q, not the energy per unit mole. So we need to find just the energy. So energy is equal to, or Q is equal to mc del theta, where the mass is the volume of water that is heated. So this is the mass. So mass in gram is equal to volume in cm cube. So mass, that is 200 gram, and the C, that is the equilibrium C, that is the specific heat capacity, that is 4.18, and the value of theta, so theta is equal to 75 minus 25, that is 50 degrees centigrade. So this is the energy that is needed, or the energy transferred to water. So that is 41.8 kilojoules. Question number 12. The element chlorine, magnesium, silicon and sulfur are in period 3. What is the correct sequence in the melting point of these elements from the lowest to the highest? So for the melting point, sodium, magnesium, aluminium and silicon has the highest melting point. Then phosphorus exists as P4, sulfur exists as S8 and chlorine exists as Cl2. So for this arrangement, we can see that more atoms are in sulfur. So sulfur is the highest among these three. Then phosphorus. So phosphorus and chlorine has the least. So chlorine has the least compared to phosphorus. So this is the melting point. And for the lowest melting point is chlorine. So chlorine. Then among the sulfur and silicon and magnesium, silicon has the highest, so this is wrong. Then after chlorine, the highest melting point is for sulfur. So sulfur or magnesium. So sulfur and magnesium. Then after sulfur, it would be magnesium, then chlorine, sulfur, magnesium, then silicon. Silicon has the highest melting point. So among this arrangement, silicon has the highest melting point. So the correct answer is A. Question number 13. An element Y reacts according to the following sequence. Y burns in oxygen to form a white solid. Then this white solid reacts with HCl to form a solution. This then reacts with sodium hydroxide to form a white precipitate and excess of sodium hydroxide to form a solution. So basically, for this total sequence, the main point that we have to highlight is that with sodium hydroxide it forms a white precipitate and with an excess it forms a solution. So magnesium is insoluble in excess, calcium is insoluble in excess. So for aluminium and phosphorus, the white precipitate is formed with aluminium and it is soluble in excess. So the answer is A. And you can find this at the end of the P3 question paper, that is the information that we have given. In question number 14, which compound would usually be added to the soil to reduce its acidity? So what is usually being used? So you have to remember that calcium hydroxide is usually being used and it is used to reduce the acidity of the soil. So the answer is B. In question number 15, the mineral dolomite is a mixture of magnesium carbonate and calcium carbonate. An excess of reagent X is added to a small sample of dolomite. Effervescence is seen and a white solid Y was formed. What could be the correctly identity of X and Y? So what is X and what is Y? So an aqueous reagent X was added to a sample of dolomite. So after adding X, so X is the reagent that is added and effervescence and a solid Y is formed. So for X we have given hydrochloric acid and sulfuric acid. If we add hydrochloric acid, then for magnesium it would be magnesium chloride, that is magnesium carbonate reacts with hydrochloric acid to form magnesium chloride and calcium chloride, and both of these chloride are soluble, so none of this would form a white solid or a white precipitate. So as they are aqueous, as they are both present in aqueous form, so they are not solid. So these statements are wrong. That is, we cannot use hydrochloric acid. Then for sulfuric acid, if we add sulfuric acid, then magnesium sulfate is formed and calcium sulfate is formed. So with sulfuric acid, magnesium sulfate and calcium sulfate is formed. And for this sulfate, what is solid? So for the solid, we have to remember that all sulfates are soluble except calcium sulfate, lead to sulfate and barium sulfate. Calcium sulfate, lead to sulfate and barium sulfate, these are all insoluble. And magnesium sulfate is soluble. So as it is soluble, so it is present in aqueous form. So this is wrong, and the solid that is present is calcium sulfate, that is the insoluble sulfate. And according to the chloride, all chlorides are soluble except silver chloride and lead 2 chloride. These two chloride are insoluble. So these two chloride are insoluble and these three sulfate are insoluble. So you must remember these two informations. In question number 16, which fertilizer contains the greatest percentage of nitrogen by mass? So for ammonium nitrate, what is the percentage of mass? Percentage of nitrogen, that is the air of nitrogen into its number of moles, that is as the air of nitrogen is 14 into its number of moles, since there are 2 moles of nitrogen divided by total MR. So we do this the same procedure for these 4 options and we get the percentages 35%, 21.2%, 21.2% and 46.7%. So the highest percentage is for the urea. So the answer is D. In question number 17, 71 gram of chlorine reacts with excess sodium hydroxide solution at a particular temperature. The reaction produces 35.5 gram of product X. What is product X? So we need to find what is product X. So chlorine reacts with excess sodium hydroxide, but it is not mentioned that whether it is a cold or hot sodium hydroxide. So it can be a cold sodium hydroxide or a hot sodium hydroxide. So the reaction of chlorine with cold sodium hydroxide is Cl2 plus NaOH. So chlorine reacts with sodium hydroxide to form NaCl plus NaClO plus H2O. So this is the reaction, and if we just balance, then there will be 2 sodium hydroxide. So the equation is overall balanced. Now this is for the reaction with cold sodium hydroxide. Now for hot sodium hydroxide, that is for hot, chlorine Cl2 plus sodium hydroxide reacts to form sodium chloride NaCl plus NaClO3. So the difference in the product is that NaCl is formed with cold and NaClO3 is formed with hot sodium hydroxide plus water, H2O. And for this balancing, to balance this equation, there would be 3 chlorine, 6 sodium hydroxide. If you remember this, then it would be helpful for you. 3, 6, then 5 sodium chloride and 3 moles of water. So this is the balance equation: 3, 6, 5, 3. So for this equation, for this both of this equation, we need to first find the number of moles of chlorine. So number of moles is equal to mass in gram, that is 71, divided by AR or MR. So 35.5, and there are 2 moles of chlorine, so into 2. So the number of moles is 1 mole. So number of moles is 1 mole, and for this is also 1 mole. So 1 mole of chlorine produces 1 mole of sodium chloride and 1 mole of NaClO and 1 mole of water. So we know the number of moles. So what is the mass of this product? We need to confirm that the mass is 35.5. If the mass is not 35.5, then these statements are wrong. So mass in gram is equal to number of moles, that is N into AR or MR. So the number of moles is same, that means mass is equal to MR. That means the MR have to be 35.5, since the mass have to be 35.5. So mass of sodium chloride is, chlorine is 35.5 and sodium is 23. So 23 plus 35.5 gives us a value that is 58.5. So 58.5, that is 58.5 into number of moles. Number of moles is 1, since they are in 1:1 ratio. So we get a mass that is 58.5. So this is wrong. Then for NaClO, this value would be above 58.5. So this is also wrong. For water, oxygen is 16 and hydrogen, that is 18, in total 18. So mass in grams is equal to number of moles, 1 mole of water into its MR, that is 18. So we get 18 gram of water, but we need to find 35.5 gram of water, so this is wrong. Then with hot sodium hydroxide, so number of moles of chlorine is 1, but for these products, so number of moles of chlorine is 1. For 3 moles we get 1 mole, so for 5 mole, that is 1/3 into 5. So this is for the number of moles of sodium chloride. So we know the number of moles of sodium chloride, that is 5/3, and its MR is the AR of sodium is 23 and the chlorine is 35.5. So in total 58.5, 58.5. So number of moles into AR or MR. So we multiply this to get a mass, that is approximately 97.5. 97.5. So this mass is not 35.5. Then for NaClO, so for chlorine it is 1, that is 1 mole of chlorine. So 1 for 3 moles, that is 1 mole of chlorine, that is 1 by 3 into 1. So the number of moles of NaClO3 is 1 by 3 mole. So we know the number of moles, so mass in grams is equal to number of moles into AR or MR. So what is the MR of NaClO3? Na is 23, Cl is 35.5 and O3 is 32 plus 16, that is 106.5. So 1 by 3 into 106.5. So the mass comes to be 35.5 gram. So the correct statement that gives the value, that is 35.5 gram, is NaClO3. Number 18. Compound Q is a white crystalline solid that dissolves easily in water. When concentrated sulfuric acid is added to dry sample of Q, steamy white fumes are formed, and these white fumes represents HCl or HBr are formed when passed through aqueous, which when passed through, that means the steamy fumes when passed through silver nitrate, white precipitate is formed, and the precipitate is soluble in dilute ammonia solution. So the precipitate is soluble in dilute ammonia solution. What is the identity of Q? So white precipitate is formed with silver nitrate, white precipitate that is soluble in excess or that is soluble in ammonia. So with silver nitrate, white precipitate is formed that is soluble in ammonia. That means white precipitate is formed with chloride, so that is NaCl or AgCl, and that is soluble in ammonia solution. So white precipitate is formed and not cream precipitate is formed, so Br is cancelled, because with Br we get a cream precipitate, but with chlorine we get a white precipitate, and that is soluble in dilute ammonia solution. Now what would be the chloride? That is sodium chloride or silver chloride. Now compound Q, that is the identity of this compound, is a white crystalline solid that dissolves easily in water. And I have mentioned earlier that silver chloride and lead 2 chloride are insoluble in water. So these two chlorides are insoluble in water, and calcium sulfate, lead 2 sulfate and barium sulfate are insoluble in water. So since silver chloride and lead 2 chloride are insoluble in water, that means they exist in solid state. So silver chloride does not react with water or does not dissolve in water. So the correct chloride is sodium chloride, that is C. Question number 19. The strength of the covalent bond within halogen molecules and the van der Waals forces between the halogen molecules vary going down group 17 from chlorine to bromine to iodine. Which row shows this correctly? Okay, strength of covalent bond and the strength of van der Waals forces. So down the group, as number of electrons increases, so the van der Waals forces increases. So van der Waals forces must increase, and down the group covalent bond decreases. So the answer is B. In question number 20, the structural formula of compound Q is shown. How many stereoisomers exist with this structural formula? So for the number of stereoisomers, we know the formula, that is 2 to the power n. So the number of double bonds, so we need to count the number of double bonds, then 2 to the power n to find the number of stereoisomers. That is, we can see that the double bond is present and the double bonded carbon is attached to two different groups. So one cis trans isomer occurs, then there is a double bond present, and this double bonded carbon atoms attached to two different groups. So another double bond is present, that is cis trans isomer. So two cis trans isomers or two double bond is present. So 2 to the power 2, that is 4. So the answer is 4. Question number 21. What is the name of compound X? So this is, here we can see that this side and this side are in the opposite sides, so they all are trans. So trans is given. Then we have to start counting that has more functional group or that starts with the functional group, that is 1 2. So 2 hydroxyl, then 3, and the double bond is present in the third carbon, so 3, that means in. So 1 2 3 4 5 6. So hex 1 2 3, hex 3 in, that is 2-hydroxyl-hexene. So it is trans 2-hydroxyl-hexene. 22. Many but not all organic reactions need to be heated before the reaction occurs. Which reaction occurs quickly at room temperature, that is 20 degrees centigrade? So which reaction occurs at room temperature? So ethene reacts with bromine. So ethene reacts with bromine, and here we can see that this bromine is used to test for ethene, that is it change from orange to colorless or it is decolorized when ethene or any double bonded carbon is present, that is C carbon carbon double bond is present, and this occurs at a room temperature. So yes, this is the answer, but here we can see that ethene reacts with water to form ethanol, and this is not water, as you remember that ethene reacts with steam at 450 degrees centigrade to 50 atmosphere pressure, 450 degrees centigrade and 250 to 50 atmosphere pressure. Ethene reacts with steam at 450 degrees centigrade to 50 atmosphere pressure to form ethanol. So this is not water, this is steam, and the temperature is 450 degrees centigrade. This is not the room temperature. Then ethanol is converted to ethene and water. Also this requires heat to decompose this ethanol. Then ethanol reacts with HBr to form this compound, that is bromoethane and water. So here we can see that ethanol, so here we have drawn the structure of ethanol, and for this ethanol, that is CH3 CH OH. So for this reaction of ethanol with HBr, so HBr forms Br minus ion. So this Br minus attacks the carbon, that is delta positive. So this carbon is delta positive and this OH group is delta negative, and since this is a primary carbocation, that means the carbon is attached to one CH3 group, so this is a primary carbocation. So this, there we have to draw this arrow from the bromide ion to the delta positive carbon, and this bond breaks. So this reaction is a slow reaction because this is a primary carbocation. So since this is a primary carbocation, so this is a slow reaction. But if suppose it is a tertiary carbocation, then it would be a fast reaction. So for this reaction it is a slow reaction, so this is wrong, because we need to find the reaction that is occurs quickly. So this is also wrong. Number 23, a section of addition polymer chain is shown. So this is the addition polymer chain. Which monomer could be used to make this polymer? So to make this polymer, first of all, here we need to find that where the hand closes or where is the repeat end ends. So here we can see that CH3Cl, then CH2, then again CH2, then again CHCl. So here we can see that if we just break this bond, so here we can see that the double bond forms, and these are the repeat unit. So the actual formula is CH2 CHCl, that is B. Number 24, which organic reaction is an example of nucleophilic substitution reaction? So this is a nucleophilic substitution reaction. So what is a nucleophile? So nucleophile is any atom or ion or something that contains lone pair of electrons. So this is a nucleophile, then this is also a nucleophile, but it is not compulsory that nucleophile has a negative charge, because if we remember the nucleophile, that is ammonia NH3, it contains lone pair of electrons. That means the nucleophile mainly contains lone pair of electrons. So lone pair, lone pair, lone pair. Okay. So for this reaction, here we can see that the reaction occurs, and for this reaction here we can see that CH3CH2Br, that is bromoethane converts to ethene. That means it is an elimination reaction where H, and from this carbon H is removed and this carbon Br is removed. So this is an elimination reaction, not a nucleophilic substitution reaction. Then here we can see that the Br nucleophile is replaced by OH nucleophile. So this is a nucleophilic substitution reaction. Then for this reaction here we can see that the CH2CH2. So for this structure CH2CH2, here we can see that a double bond breaks and H and Cl are attached. So this is an electrophilic addition reaction, that is HCl. So from this double bonded carbon,
this attack occurs, and this occurs in this way that first of all hydrogen attached to this carbon, then chlorine attached to this carbon. So this is an example of the electrophilic addition reaction, not an nucleophilic substitution reaction. Then here we can also say that there is also a this is also a substitution reaction, but not a nucleophilic substitution reaction. So the correct answer is P. In question number 25, so for this reaction here we can see that citric acid is converted to this acid and Q is an intermediate. Which reagent are needed for each stage? So for each stage, which reagent are needed? So here we can see that carboxylic acid is present. Here also carboxylic acid is present. So no change occurs. So carboxylic acid remains the same for the conversion. So LiLH4 causes the conversion of carboxylic acid to alcohol. So this statement is wrong. That is LiLH4. NaOH is also wrong because it also converts carboxylic acid to form alcohol. And here we can see that no other reagent is present that can oxidize this alcohol. So these two options are already wrong. Then for concentrated sulfuric acid, so if we add concentrated sulfuric acid, then concentrated sulfuric acid causes the conversion of alcohol to an alkene, that is OH removed from this carbon and hydrogen is removed from this carbon or from this carbon. Suppose we think that this is carbon, then OH removed from this carbon and hydrogen is removed from this carbon and double bond is formed. So okay, double bond is formed. Then if we add LiLH4, then it causes the conversion of carboxylic acid to alcohol. So this is wrong. But if we use hydrogen in presence of nickel catalyst, then in the presence of this hydrogen, what occurs that initially the double bond is present, as I have mentioned. Then the presence of this hydrogen causes the double bond to break and two hydrogen are attached to this carbon. So ultimately we get the same compound. So yes, the option is A. Question number 26. Glucose can be used to prepare this substance, a compound used as a sugar substituent or substitute. Which reagent may be used for the conversion? So here we can say that OH groups remains the same and there is no change to the OH group. Just what occurs that the aldehyde is converted to alcohol. So aldehyde is converted to alcohol, that means it is reduced. So aldehyde is converted to alcohol, it is reduced by reducing agent such as LiLH4 or NaBH4. So acid by potassium manganate causes oxidation, but we need reduction, so this is wrong. Then sodium hydroxide. So sodium hydroxide also has no role in this reaction. Then tolerance reagent. Tolerance reagent is an oxidizing agent that oxidizes aldehyde to carboxylic acid and it causes the oxidation. Also tolerance reagent produces a silver mirror with an aldehyde that causes the presence of an aldehyde or that determines the presence of an aldehyde. But for the reduction of aldehyde to alcohol, we need NaBH4, that is NaBH4 or sodium borohydride. So this NaBH4 is needed to convert an aldehyde to an alcohol. So the correct answer is B. Number 27. 3-methyl butanone is treated with alkaline aqueous iodine. The mixture of product is then acidified. Which compound is present in the final mixture of products? So 3-methyl butanone. So butanone, METH, ETH, prop, butanone. So since it is butanone, so CO bond is present and 3-methyl, that is 1, 2, 3, that is CH3. So CH3 and this is the overall structure. So this butanone is reacts with alkaline aqueous iodine. So after the reaction with alkaline aqueous iodine, what occurs that CH3CO group is present. So the structure converts in such a way that after the reaction with alkaline aqueous iodine, CHI3 forms, that is methyl. So iodoform is formed, that is CHI3. After the formation of CHI3, what occurs that CH3 CO and O ion is present. So after the reaction with alkaline aqueous iodine, this iodoform is formed that causes a yellow precipitate, and this ion is formed, that is CH3 CH3 CO is the same, and O is added, and this is a charge of -1, that is a negative ion is present, and the mixture of product is then acidified. After it is acidified, that means the reaction with H plus ion. So after the reaction with H plus ion, what occurs that an acid is formed, that is CH3 CH3 COOH. So this acid is formed, and this is METH ETH propanoic acid. So propanoic acid and methyl. So methyl propanoic acid, that is option C. 28. At room temperature, propanoic acid was reacted to produce sodium propanoid. No gas was produced during the reaction. So no gas is produced. That means there should not be any carbonate, CO3 minus. So there should not be any carbonate. Okay. What could the propanoic acid have reacted with? So sodium propanoid, that means it is not sodium hydrogen carbonate, because after the reaction with sodium hydrogen carbonate, sodium propanoid forms. Okay, but a gas, that is carbon dioxide, forms, and here it is mentioned that no gas is formed, so this is wrong. Then here also carbon dioxide forms, so this is wrong. Then here the reaction with Na2SO4, probably, I am not sure, but here sulfur dioxide is formed, maybe, but this is not given in our syllabus, so we can just avoid. But we can confirm that the reaction with sodium hydroxide causes the formation of sodium propanoid, and also water is formed, that is H2O, and this water is in the liquid form, so the answer is B. 9. Ethene is reacted with steam in presence of concentrated phosphoric acid. So ethene reacts with steam in presence of concentrated phosphoric acid to form ethanol, that is CH3 CH2OH. So ethene reacts with steam to form ethanol in presence of concentrated phosphoric acid. The product of this reaction is added to acidified potassium dichromate and heated under reflux. So heated under reflux for 1 hour. So acidified potassium dichromate causes the oxidation of the ethanol, and since it is heated under reflux, so it is heated under reflux and not distillation, so no aldehyde is formed and carboxylic acid is formed. So this ethanol is converted to carboxylic acid, the CH3COOH. So this is the carboxylic acid, that is product X. Then butene is treated with hot concentrated acidified potassium manganate. So butene METH ETH but. So it is reacted with hot concentrated acidified potassium manganate. That means the double bond breaks. So the double bond breaks, and since the double bonded carbon is attached to one hydrogen and one carbon, so carboxylic acid is formed, that is ethanoic acid, CH3COOH. And let's suppose if it reacts with cold dilute acidified potassium manganate, then instead of breaking the double bond, the double bonded carbon is attached to OH groups. But since it is hot concentrated and not cold dilute, so this is wrong. So we get this product. So this is product Y, and here we can see that the product X, that is ethanoic acid, is same as the product Y, that is ethanoic acid. So X is same as compound Y. Number 13, a sample of ester is hydrolyzed. The product of the mixture is treated with hot acidified potassium manganate. What is the final carbon containing product? So ester, that is CH3, CH2, CH2, then COO, then again CH2, then CH3. So what occurs that this ester is hydrolyzed, that means this bond is broken, and the product that we get is CH3, CH2, CH2, COOH, and ethanol, that is CH3, CH2OH. So this acid and this ethanol, then the product is then treated with acidified potassium manganate. So acidified potassium manganate is an oxidizing agent, and it causes the oxidation of the ethanol to ethanoic acid, that is CH3, CH2, CH3. So this structure is CH3, COOH. So ethanol is converted to ethanoic acid, and this is also an acid, so no change occurs. So this is the product and this is the final product. So CH3COOH, that is ethanoic acid, and this acid, that is 1, 2, 3, 4. So butanoic acid, 1, 2, 3, 4, butanoic acid. So the answer is C.